Welcome and thank you for coming. Um, I'm going to try to convince you that test architecture is a real thing. My wife's daughter gave the 17th of May speech at her elementary school, and she did something a bit odd. She kind of made it a argumentative speech to kind of convince the audience instead of just saying, "Oh, it's great, we have a constitution." And so, yeah, not so much argumentation, but I hope you'll be convinced afterwards. Quickly about me, I am a senior test automation engineer at NEAT. I have come here to the Numedal Valley from a place that's often called Video Valley, Fornebu, because there's a lot of people who work with video conferencing solutions, embedded software and video conferencing. Anybody else come from Video Valley today? Yeah. I think there's 3 talks at least from the Valley today. So I do automatic end-to-end testing of embedded software on custom NEAT hardware targets. So this is software that includes an operating system, custom drivers, working on highly specialized custom hardware, and often we have a lot of test instrumentation activated. I was here last year. I was here the year before. This is the 4th year I've been here. Thank you for putting up with me. Last year, I had a talk. Maybe some of you caught it, and I was talking about the art of living with broken things. I was talking about the art of living with broken tests, that broken tests actually are something very good if your tests are breaking because there's a problem, for example. And there was this Japanese art, and I thought that was nice, right? Seeing the beauty in brokenness. This year, I also would like to use a kind of touchstone to frame my talk. This will be really clear. This is actually from the Numedal Valley that we are in today. It's further up. It's from a place right next to Teigen Skole. I don't know if anybody ever has heard of Teigen Skole, but you have this pasture path. And you can see the scale. The scale down there is 50 meters. It's a really, really big thing, a really big path. There's trees growing up in the roadbed, and it's a bit sad. I walked and bashed through the bushes here and bashed through all the trees, but there was beautiful steinwork on all the corners, and people had been working on this for many, many years because this was their lifeline. This is what made their life further up, an hour up in the valley, possible. And I'm talking about architecture, and there's a bittersweet point about this because I think we can put a lot of effort into architecture that maybe it was really good, and then you move on to the next job and it just sort of disappears. I have a lot of babies I've sort of been involved with that I've abandoned later in my career. So a little bit of humbleness, I guess. Why? Yes, here's a picture of them. Not the one I was showing you at Teigen Skole. Another one that I was at last Saturday. I have been wandering up these pasture paths. In Norwegian, it's seterveg, and they're often very beautiful. They're often very steep. They're often hard to find. They're forgotten. It's kind of cool. I can recommend doing it. Let me tell you what these were used for. They were used for transhumance. That's the French word that is actually used in English. It means humans moving. It also means animals moving. So between where the animals are down in the valley and then up to the pastures, the mountain pastures in the summer. The word transhumance comes from French because this is something that's done a lot in the Alps. If you like the French cheese Gruyere, for example, or any of these, they kind of have to be. There's the laws around the cheese say you have to get this from the mountain pastures. The cows have to be up in the mountain pastures. But transhumance was also a very, very big thing in Norway. It's called setrin. I do my R with the French R because I lived in France for a while and can't roll the R. So setrin, like a Bergen person might. But this was done a lot in Norway, particularly, as I've just mentioned, further up the Numedal Valley. There was very limited space on the valley floor. It's a beautiful U-shaped glacial valley with steep sides, but there are mountains on each side, almost 1,000 meters difference between the bottom and the top, and these pasture paths are everywhere. The one I showed you initially, if you drive past it on the road, it is utterly invisible. The road cut just took off the bottom, and you have to actually bash through bushes until you come into this beautiful snaking road going up a very steep side of the valley with stonework. It's interesting and fun to explore. I can recommend it. And keeps you in shape because these things are on the bleeding edge of too steep. Why am I talking about this? Well, because I want to talk about architecture. I want to talk about test architecture. It's going to be focused around automatic end-to-end testing, but I think it's applicable to other forms of testing. There's a problem for me. Usually I try not to invent my own definitions, but I feel when I've Googled around and tried to find a good definition of architecture, it's been extremely unsatisfying. And I today also want to talk about not just software architecture, test software architecture, but also enterprise architecture. Virksomhetsarkitektur in Norwegian. So I'm trying to hit something that would actually be a good definition, and as I've been slogging my way up these pasture paths, a Setterveg with a heavy backpack on, it gave me a lot of time to think, and I was thinking about, well, these pasture paths and life, the Settering life that they enabled, has some parallels, I think, with the kind of architecture I'm interested in talking about today. This is a very thoughtful organization of life further up in the valley. People figured out how to make it work. They built artifacts. In the valley, it was primarily these pasture paths snaking up. And they had ways of using them. The people would drive the animals up in the spring. The path obviously had to take into account the environment, which was a difficult environment. And the point of this was to reliably create value. So, a life, basically, the possibility for survival in the 14, 15, 16, 17, 18, 1900s up in Numedal. Produce meat, cheese, hides, wool, timber, all these things, and also preserve value. And this was an interesting point because these paths had to be done in such a way that they were not dangerous, that the animals didn't get hurt or the people didn't get hurt coming up, and especially they didn't get hurt coming down, because these paths were the lifelines to the life in the valley. They had to cut the hay, cut the grass up in the mountain and take it down these paths very carefully with oxen in hay carts. And this is what made that life possible. So what's the relationship with what I'm going to talk about today? Well, this sentence applies to, I hope, everything I'm going to present. I'm going to talk about the thoughtful, because there is some thought that's gone into it, organization of built test tooling artifacts, and also how we use these. So the human organization of a test team working with these, the ways we work with them, the way we take into account our specific environment. I'm going to be talking about end-to-end testing on specialized hardware with embedded software. So that's an environment. It's a very special environment, just like Numedal is a very special environment. And why are we doing this? Because we want to reliably create value, right? Testing, I believe very strongly, should be the thing that allows your development teams to move fast and break things, right? Don't move fast and break things people are actually using. Let the tests allow you to make those radical changes you need, the refactoring, fixing up legacy code, and let the tests have your back and catch you. So reliably create, and yes, preserve value, because if we don't catch these things and accidents happen, then we lose value because we get a bad reputation, we lose customers. And we have a lot to live up to because we're called neat. I'll talk about that, right? So we're setting the bar high. So I hope you see maybe where this is going, that there is a connection, right, between what I've been sort of plotting up with a heavy backpack and meditating on and what I'm going to talk about. So I'm not proposing this as a general theory of architecture, but I think the pasture path, that sentence I just mentioned here, crystallizes the interplay between three concerns that are, I believe, most relevant when you're talking about any form for architecture, including buildings. And that is people, the environment, and built artifacts, right? The people have to adapt to the environment. The built artifacts have to be adapted to the environment. The environment doesn't really adapt, except, well, now we're kind of changing it in the last few years, but I'll get to that at the end of the talk. But then there's one more side to that, and that is the people adapting to the possibilities opened up by the built artifacts. And I'm going to talk a lot about that. And you can see that if you take the 420 bus, I can recommend not driving, up Numedal Valley, then you can see how the people there in this tiny, narrow valley, sometimes you can almost spit across the Numedal's Logan because it's just in a stone gorge, right? How they were able to make a life there, and they had these nice stavkirker, these old churches, and a lot of them they got rid of sort of 100, 200 years back because they were too small, because there was too many people that were able to eke out a life in this rocky, narrow valley because of Setrin, the transhumance. And I think these concerns are correct, because just going from the complaints about built architecture, buildings, right? Most people say, oh, I hate that building. Why do you hate that building? Because it doesn't fit in the environment. Or I hate that building because my company has an office there and it's totally unusable. It's not adapted to the people. Or maybe it's just a mess. Maybe it's just not well built, right? So I think these are the concerns we should think about when we're talking about architecture, the primary ones. So there is not any sort of, I feel, unambiguous, great definition that just stands out of architecture. But I found something that was really nice. The two fundamental laws of architecture, and I think this is quite true. Everything is a trade-off. And the second one, I like this one, why is more important than how. And I'll just take it back to the pasture path, right? The pasture path was always, and I've experienced this with a heavy backpack, at the bleeding edge of too steep. Why? Because they had to maintain these things, this intricate stonework there, for example. So you always had a compromise to be made between making it safe to go up and particularly go back down with hay, timber, minerals. They had mines up there, lots of heavy stuff with oxen, right? Surely happened, the carts got out of control, animals, people got killed, right? So you had to hit the right balance between, yes, this road, I can maintain it with the people on my farm, and no, people aren't getting killed every year, right? And then the other thing, why not how? There's something called vintersättring, which was a great thing I learned about when I started looking at this. And vintersättring is winter transhumance, if you will. It was just flipping things over. And a few people would go up on the mountain, and they'd have a barn up there, a shed or something. They'd cut a lot of hay all summer. They'd stock it up. They'd cut a lot of firewood. They'd put the animals in the barn, and they'd put a log in the fire, and they would move up to the mountains in October, November, instead of April, May, right? So they'd flip the whole thing around. And that way, well, there wasn't any work to do. They could sit inside, enjoy, feed the hay to the animals, right? And this is doing it completely wrong. No, you have to go up to the high pastures in spring. No. We know why we're doing this. This works, you know. Sven got killed last year when the hay cart got out of control. We're not doing that again, right? So it's the why that's much more important than the how. And I, just as a sort of a side note, I've never experienced that dogmatism has ever had any beneficial effect in software engineering. So yeah, and I'll come back to that as well. So here's where I'm going to focus on the talk. I'm going to start and actually talk about these three concerns. So the test tooling artifacts, and one of the things I'm going to talk about is a page object model. Another thing, adapting our test artifacts, our test rig, to remove blind spots. That'll be the second point about artifacts. After that, I'm going to talk about environment. I mentioned that, like Numedal, automatic end-to-end tests on real hardware with embedded software is a very special environment. That's why we're here, right? That's why there's an entire conference about embedded. It's special. It's got its constraints. There's a nice talk about doing TDD with it before, but you have to do it in a special way. After that, I'm going to talk about people. I'm going to talk about a tool that saves software teams from people like me. People wearing an architect hat, and from a lot of other people. And then I'm also going to hop on the machine learning bandwagon because I think we have a success story about how we have been able to auto-triage known failures and solve a real problem with test automation. So this will be a little bit of extension of my last year's talk about the art of living with broken things, broken tests. So that's the plan. So let's start and talk about artifacts. The page object model. If you're going to test the GUI, well, you know, obviously you don't want to test the GUI, right? So if you don't need to test the GUI, don't do it. But I work for a company called Neat, right? And we have these devices. We have a GUI. We try to make the process of setting up your video conference devices neat. So there's a lot of, you know, going through the setup, the out-of-box setup in the GUI, and then you have to have a GUI. So we want tests. We want to actually ensure that this experience is neat. And I will get further, come further in the next part of this artifacts chapter of my talk about one way we're actually using testing to try to ensure it's neat. But if you're working with the GUI, you have a lot of challenges. So the page object model is probably testing test automation's one own design pattern. If you know another one, come up and tell me afterward. I'm really interested. One of the big things it does is it makes your test code dry, right? Don't repeat yourself. If you have GUI references spread out all over your test code, right? This is an absolute recipe for disaster because if you know one thing about a GUI, it is that it is changing all the time. We have a lot of very talented designers, industrial designers at Neat. They're always improving the GUI. That means they're changing the GUI. They're making my life as a test automation person difficult, but you just have to say that's that. So the page object model, you concentrate all the GUI references in one place. And more than just GUI references, actually. I'm going to go through the list of things we have concentrated in this page object model. It was maybe Simon Stewart, maybe Sam Woods, maybe Martin Fowler. Yeah, if somebody knows for sure, let me know. So what should a page object model do? So it represents, a page object model is a set of classes. These classes map pages or screens, right? We're not a web solution, we're an embedded software solution, to classes. These classes represent those screens. They're proxies in our code for dealing with those screens. So one of the big things they do is they encapsulate all the GUI references, so they're not spread out all over the code, which makes a maintenance nightmare. And I mean, basically, if you don't have something to do this and you're testing the GUI, you will not succeed because you'll have so many broken tests every time the GUI changes that you'll never get a good test run that actually manages to test your solution. The other thing it does, and this is nothing controversial, it encapsulates GUI operations, like, we have a Wi-Fi screen where you connect to Wi-Fi. And so my class has a function, connect to Wi-Fi. And then there's a last one. It's not universally recognized as something, but I will try to convince you. It should be a part of a page object model, and that is encapsulating navigation paths through your application. How do we do the first thing, the mapping between the screens and our page object model classes? We use a framework which I recommend wholeheartedly, which is called Python Behave. And it's a BDD framework. And this is just a little snippet from some code that's exercising, going through the GUI and going to change a setting. What we do to map to the actual physical page in our application, our screening application, to the page object model in our POM classes is we just say, hey, I'm on the Zoom welcome page, right? So it's very declarative. And this actually has worked out well, because one of the things when using this BDD kind of approach, you want your tests to be readable. That's kind of one of the selling points for this. And if you start by actually being required by the framework to say where you are in the GUI, that actually really helps, right? So we came very quickly to, oh, this is a good thing to do. And this also enables something else that I'm going to come to in a minute, but we'll just let it go for the time being. Is it dangerous doing this, right? Some people would look at this and say, ooh, that looks so scary. Is that reliable? Yeah, it is, actually. You can see the check-in is 2 years ago for this code, and we haven't had to change it. We made it a little bit forgiving to take into account, if we're thinking about our triad of concerns, people, environment, and built artifacts. We want to take into account the human weakness, and we sort of fix up whatever you've put in to ensure that we actually get something out that is a class name that we can pull out of a class register we have for these page object classes. And so, yeah, it might look dangerous, but yeah, it's been 2 years. It's worked great. Yes, but we can actually make things a little bit nicer. We can adapt to a artifact that's built by somebody else, the Python Behave, and we can actually rewrite this in a little bit of a fluent way. It's quite cool. Python Behave is a super powerful, super simple, just makes sense kind of framework. And so you don't even need to put things in quotes. It will parse out if you just say the current screen is page name, and this maps to Python functions. And these functions just need to be in the Python path and have a decorator. Here you see step. Most people use the more explicit decorators, given, when, then. My experience, when you're writing these test step implementations, you actually never know how you're going to use them. So if you use Python Behave, just small tip, use step. Right? Don't say this is a given or this is a then or this is just experience has said use step. And you can also overload things, and you can put different step texts to access the same function with different texts so that your tests read well. And that's a very, very cool feature of Python Behave. So I was going to tell you, I promised, why do we require you to start by saying where you are in the system? And that's because our page object model encapsulates navigation paths through our system. And so as long as you declare point A, starting point, then this is basic, computer science 101, we can work out the path to where you want to go without you needing to spell it out in your test. This was the original sort of thing when we were doing this. What's the problem with this? Well, our designers change the flow all the time. They make it better, they make it simpler, they cut out steps, right? And if we have these paths everywhere in our Behave gherkin features, then this is a maintenance burden. And it's just like that pasture path. We need to take into account its maintenance. We want this to be reliable. Remember when I was talking about that, we want to reliably create value and reliably preserve value. If our tests are broken because there was a big change in the GUI, right, we're not reliably preserving value. We're not reliably creating value because that sort of safety net that the software developers had isn't working. So then, when you have a bunch of broken tests, when is it that all the really, really awful problems come into your code base? Yeah, exactly at that moment when your tests aren't working. That's just how it works. So how do we do this? Well, Guido von Rossum, BFDL, benevolent dictator for life of Python, had a really, really influential essay he wrote a while back, a long time in the 90s, on graph theory. And he was doing showed how you could use recursion to work out a shortest path between A and B in a directed acyclical graph. He got a reply to this, actually, was from somebody that said, you don't have to use recursion, you can use queues. So this is actually the algorithm from that reply. So that's what we use to work out the shortest path. That's a kind of cool thing in test code, that we've got a cool little algorithm. Yes, now I'm going to talk about how we handle GUI references. So as I mentioned, the things that the page object model encapsulate, one of the primary things that they always do is they encapsulate GUI references. And here we have several nods to human weakness, as we should, just like the pasture path can't be too steep for the humans and the animals to get up and get down safely. Great thing in Python called named tuple. This was really, really useful for this. When I did the first sort of iteration on this, I just used a dictionary and thought, I'm not going to mess this up. I can just put the references in a dictionary and reference them correctly. All right, first check-in failed miserably because I made 3 or 4 errors all over the place. And it's like, even if you're wearing like the architect hat, or especially if you're wearing an architect hat, you learn very, very quickly that you have to be humble and you have to recognize your weakness. So I looked and found something called named tuple. I actually used the one that's defined in typing because that's the one that gives me this. Basically, it's a little bit complicated to declare, but if you, amongst other things, MyPy will catch it, but also a lot of IDEs. I work on Linux, but use VS Code, so I don't know what that does for me for nerd cred. But if Vim doesn't support this, then please write a plugin, to make sure you do. So this actually, if I'm defining my selectors, these are GUI selectors. If I reference them in the same class and I reference them incorrectly, I spell it wrong, I get immediate feedback. And also MyPy, the Python type checker, gives me feedback. And so this is a way of making sure that when you use a reference to the GUI, a selector reference, so a selector is finding a GUI element that you're going to click on or do something with, right, that it actually is defined in that class. We also use a nice package called Dictify, so you see that the selectors themselves are wrapped in this cell class. And the Dictify Python package allows us to define what attributes we can use in our selectors. So there's a lot of different attributes supported by the GUI automation framework we're using, but this also makes sure the one you're trying to use actually exists. Otherwise, you get an exception. So again, taking into account human weakness to reliably create or preserve value. The thing that's sort of awful about wearing an architect hat is you come up with ideas that you think are great, and then you see how people murder and destroy them. And you start to think, okay, maybe they weren't as good as they were before. And so I saw something in a merge request that looked like this. We had a big, ugly, long list of shared selectors, things that we found in a lot of different places in our GUI. And that was actually maybe an okay solution, I felt, just to have the ones we shared just in a file with a bunch of constants. But then, right, why did you write this complicated named tuple construct just basically to point towards a constant that was defined in a file, right? This is, there's a word for this, it's called cargo cult programming. It's where you sort of ritually include certain complicated structures in your code to appease the code gods or the software architecture, and it's not a good thing. So you have to stop yourself and ask, why am I doing this? And that's coming back to that second law of architecture. Why is much more important than how. So I think probably one of the best ways to do it would just have exit screen selector in the click right here. Right? That'd be a nice way to do it. That would solve it. We don't need this stuff right here. Right? I hope you agree. It's complication that does not give us anything. So why are we doing it? And yeah, that wintersättering thing I thought was a nice idea that, we're crazy. We go up to the mountains in November, but we know why we're doing it. It saves lives and it works. So this is how we actually do it. We do it a little more complicated actually. We just have an accessor that is getting us a shared tuple, or maybe we have them grouped as a set of shared tuples that we can get. You get all the sort of red marks if the sign-in text selector doesn't exist. That works. It's type safe. MyPy will catch it. The Python type checker linter will catch it. Why are we doing it so complicated? Well, that was because every solution creates its own problem. And after we had refactored out the shared references into a big ugly list of shared references, what happens? Oh, somebody doesn't read that list when they're making a new page object model for a screen, and they define exactly the same selector in that new class that it exists in our set of common references, right? And yeah, we tried to solve duplication in code, and we introduced duplication in code. So I personally believe, as somebody who lives in Scandinavia and is very conflict shy, that one more linter will probably solve every problem. So I had to write a kind of a custom linter, and so since it was already running through, iterating through all our page object model classes and looking at the named tuples, I could just put these things in a named tuple and make sure it gets put into that linter so that our linter finds duplicates within several page object model classes themselves, or within our store of common references. So, yeah. So let me transition a bit and go on to another something that we have been trying to do with our test tooling, these test tooling artifacts we've built up, and that is to avoid blind spots. And I think this is an interesting case, so I want to share it with you. I promised in my blurb for this talk that I would give you some questions, some guiding questions to think about when you're doing software or test architecture. And one of the things I think is really important is to ask yourself, what don't we see? And I'm thinking about test results specifically. What is hidden? What don't we see but we should see? So there's a nice AI-generated picture of a black hole, and you see the event horizon where the light goes out. And so what don't we see? I actually presented this here as a great success earlier in years past at this conference. I'm very into tracking test results over time. And this was some flaky functionality. And you see flaky, 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 nope. Right? And that was great because I said, oh, right, I caught a regression, even though the functionality I was testing was flaky, right? So that's a victory for humanity. But then after that, I sort of thought, behind the blue lines, behind the successes, there is also a lot of pain, actually. If you have a problem in your system under test, right, you have a couple options. The normal thing when there's a failure is you just stop. Right? So I'm trying to perform this complex operation. It's got a retry button, but maybe it fails on the first thing. Okay, I'll stop. But our customers are dealing with that retry button, right? They don't stop. They say, oh, I couldn't get my devices paired. Yeah, retry. And how many times are they clicking on that retry? So here's like the black hole, right? You had one failure. The tests just say, oh, that's failing, 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 failing. I want to know how bad it is. I also want to know if it's getting better. So I want to avoid that black hole. And I don't like inventing my own terms. There's this idea in my head, microfailures, when I thought about this. The opposite of a macro failure, when things just don't work. And so I Googled and found a great article about microfailures. You know what a microfailure is when you see one. Has anybody seen the Microsoft? Don't show me this again. Yes, this is a microfailure because usually it is an annoyance on the way to successfully signing in. But it does irritate you. A microfailure, from the article, is to a macrofailure as satisfaction is to delight. So it's a question of degree, not an absolute difference. But I sort of thought about something else here. There is also a opposition between satisfaction and a macrofailure, right? If you try to log into your bank and it just doesn't work, you are not satisfied. Right, you got there, maybe after trying Bank ID 5 times or something, and you finally got in the bloody thing, right? You experienced macro failures. And the absence of macro failures is delight. So if we take this axis here, right, satisfaction is the absence, just satisfaction, like, okay, yeah, I got logged in, is the absence of a macro failure. But delight is the absence, the opposite of micro failures. And I work in a company called NEAT, right? And our name means that we have this delightful, friction-free experience. Where you don't need to use a manual. So there are some mitigation strategies for microfailures suggested by this article. We should re-gear systems to track and monitor microfailures. We should leverage detection to predict when they occur, and we should embed continuous improvement efforts. The basis of prevention, says the article, is detection. Here's how we do it. We have a little functional framework that is trying to do things that are difficult. We call it henrule. You may have heard that Norwegian word. But what we do is we just take a trace to say, okay, we're doing that thing that's difficult. And then it tries again several times before it gives up. And each time, maybe with a different failure, it registers a microfailure in the system. So this is terrible data visualization, but you can see like the yellow colors are microfailures and the red colors are macrofailures. And so we can see over time, and this is split up by different types of software and device types, what the trend has been. And so, well, why are we doing this? Because I have no idea who Johnny Jones was, but I thought this was a great quote. What gets measured gets done. What gets measured and fed back gets done well. So we can feed back and measure. We can try things and we can figure out how it's working and take small steps to be neat. Environment. Here is an AI hallucination of Numidol, and it's actually fairly accurate. Our test automation environment is chaotic. It's dominated by global state and randomness. There are a ton of exceedingly hard to control variables. This is one of my absolute favorite test failure. If you see down in the corner, there is one of the founders of my company. This is from a video device sitting on a shelf. It was supposed to be seeing a test instrumentation image that we were faking the camera, but it saw a real person at 12 in the morning, Ivar. That failed the test. This is the stuff that, right, we have to live with in test automation. It is a chaotic environment. Are meteorites variables that are relevant for our test? Or, well, they could make the test fail. Yes, so they're in scope. They're not relevant because if a meteorite hits Oslo, I'm not going to be checking my test results. So how do we deal with this? And this is what we've done. We've put in, it's kind of hard to see the names here, but we've given a name to different kinds of trends. We work them out using some functional style code that basically one function matches one trend. And we don't focus on individual failures as much. We focus on trends. Here's what the code kind of looks like. So you see flaky, intermittently passing, regression, etc. All these things have a definition. We go through them sequentially, so it's kind of procedural and functional. And when we get a match, we stop and we say it's that trend. And so when we're doing failure triaging, this is from we use Elastic Stack, our Kibana dashboard. We just focus mostly on the tests that have bad trends, right? Because that's how we see clearly in our chaotic environment. And we're actually storing this as an attribute of every single test result. So every single test result has its own context, right, which gives meaning to the result, the whole history for that little test scenario. And we also have a separate display for fixes because we want to see that. So I lived in another place a long time ago where I used to surf, and you had to get up early in the morning, not because I was a morning person, but you wanted to get up before the local wind started blowing that made small waves chop, which destroyed the long period swells, the long period cycles. And I see like the chop in our test environment, chaos, flakiness, as something that makes it really hard to see the long period significant problems. So this is a way to address that. As I'm trying to hit the point home, how do I live in this difficult environment, right? Numidol is not just a difficult environment, also test automation, testing of embedded software is. Yeah, so now I'm going to go on to talk a little bit about people. A fast point about something we have that saves people from themselves, particularly people wearing an architect hat. And we have a nice, talented tool maker that created a Slack interface. We call it Autobot. I think it's actually a software package, Autobot, where we can order test runs outside of the nightly test run. And you can run it against your own branch with, if you're working on some test automation tooling artifacts, you can specify domains, you can specify X number of domains. And yes, it also gives you nice help. This changes everything because I mentioned my own human weakness and I have been humbled by it many, many times. So instead of, yep, it's about time to go home, merge. I don't do that until I actually have got test runs, and these are relevant test runs because we're able to specify by domain, by device type, where we can specify that it was software from a specific build to try things out. So it's not just me, it's also all the developers in the house can also get a customized test run to validate their changes so that we reliably create and preserve value. This stops things like this. This is the overall number of behaved scenarios that we were running in a day. Somebody made a mistake there. Oops, went a little fast. Those dips are very, very ugly. This makes sure that we don't get in those things. Auto-triaging. This is the last thing I'm going to talk about. I see time is flying. Yes, this is the one that changes everything for people. You see this computer screen icon here in a couple places. We have created a machine learning model that auto-triages known failures for us. We're using scikit-learn, really recommend it. Random forest, which is really good at working against overfitting. Which is basically connecting the dots wrong. This is a step further from something I presented last year where we were assigning a category to every test failure. This has been more successful. Now, we don't have a closed set of categories. We have what we call our bagged list. It's basically failures we've caught with our test automation, things that we know are going to continue failing. Maybe software regressions, maybe problems with test infrastructure, test tooling artifacts. But we know this is going to fail, and so we can just add new things there, tag a failure, and the machine learning model will auto-tag it for us. Yeah, it's tagged in the moment when the results are sent to Elasticsearch. For the machine model, we denormalize, we put a bunch of fields together to make a document, which I sort of feel like is what I would need to see to determine what this test is, and we show the model it. We retrain the model every day if needed. Here you see the GUI. We have this known issue. You click on the known issue button and you choose from the list. Easy as that. How do we do this? Well, behind the scenes, we're actually using a confidence threshold. Machine learning, as you probably know, really is basically statistics and probabilities, actually. I have a couple fields in Elastic. I have the debug assumed issues, which shows everything the model thought it might be, and then I have a way of working out, well, is the confidence high enough that I'm going to accept its judgment. And this is how it works. We auto-scrub if the model is 60% confident that the known issue that it thinks it is, that it's that known issue, or if there is a 50 percentage point or greater gap between the next known issue. Because it usually always spits out 3 or 4 things that it thinks might be that, but many of them have very low probability. This initiative has exceeded all expectations. We have concluded that the model does a much better job than we humans do at accurately connecting failures to known issues and not erroneously saying, ooh, yeah, I think that one's that one. Has anybody read Joseph Kahneman, System 1, System 2, Think Fast Tänk snabb och långsam. Think fast and slowly. Yeah, we're really, really bad at these snap decisions. Machine learning models here are incredibly good. We have basically not seen where it's doing it wrong. Very often we see, oh, that test that was always failing, it didn't get auto-scrubbed today. Yep, because it failed a completely different way. One side note, if you're going to do anything with machine learning, you have to have data, right? You have to have good data, right? So that seems to be a universal truth. And this allows us to adapt our ways of working, just like the people in Numedal were able to adapt their way of living because they built these pasture paths. This allows us to change, actually, what we're doing and being a lot more effective. And it allows us to solve that awful problem. What do you do with tests that you know are going to fail? The usual terribly unsatisfying solution to that is just turn them off. You forget to turn them back on, and you don't see when the problem gets fixed. And you probably, many times, aren't going to get sort of an ahead warning that the problem is going to get fixed, right? There's a lot of things that happen in the house you have no idea about. I showed you that trend correction list. Ooh, it popped up, it got fixed, and then it stops getting auto-scrubbed, for example, because it's passing. Rounding off. Book recommendation, very fast. I can really recommend this book. It's talking about setting in Norwegian, and even mentions vintersetting going up in November. There was a great quote there, and he said, there was a character in the book that said that in the start of the 20th century, every year something new popped up and made the old things unnecessary and made the people who knew all about those old things unnecessary, but it wasn't like that before. Before, it was the grandparents' knowledge that was the most valuable that existed because life had been just repeating itself for hundreds of years. But I would like to say that maybe some of these old ways of doing things we shouldn't just dismiss. I would say, for example, that many people in Norway, including in Numedalen, have demonstrated a great talent for living and having a social organization adapted to the limits of their environment. This is Earth overshoot since 1970, and it's how early in the year we overshoot the Earth's resources. And for Norway, for the world, it's 1.7 Earths. For Norway, we need 3.6 Earths. So I'm really interested in this way that we as human beings, we have this ability to build artifacts that allow us to adapt themselves to our environment and the limitations of our environment. I was really lucky. I worked before at Tomra, making these reverse vending machines, and that's a nice way of starting to adapt to the limits, not of Numedal, but of the Earth. Actually being able to recycle plastic, and you can now buy bottles that are 100% recycled, not just downcycled. But I think we can go further. Here's Greta Thunberg blocking a Norwegian oil and gas facility, and people would say, "Oh, she's wearing a plastic jacket." And I kind of imagine her jacket is made from recycled plastic, but I would like to be able to say, you know what? You can't say she's a hypocrite. Her jacket does not come from oil. It comes from recycled jackets. I have been very lucky. I went on to Neat. Neat invented what's called neat symmetry, cuts up the image, and gives everybody their square. So you're sitting having fun in a meeting room, what you actually see on the screen, what you focus on, is everybody gets their own square. It solves this awful problem I have experienced before without Neat, where I rang in from home in my little square and I felt like I had nothing to contribute. I was outside. It wasn't because there were bad people in the meeting room. It's just because the technology did not do that, support that, did not make it so I was included. So this is called neat symmetry. Some like to call it neat likestilling. And everybody gets their own square. And this makes remote meetings work. And I can vouch it actually does. It makes it possible to have effective meetings without driving into the office or flying across the world. And I think if people could make a life within the limits of Numedal, and the valley could effectively support a much larger population than otherwise because of these paths snaking up there, then that inspires me to think that we can do this with other things and we can live with the limits of our planet. That's everything for me. I think we have a couple minutes left for questions, 7 minutes left. If there's anything you think about, you can also contact me there. Thank you very much.